Okay, AES, Advanced Encryption System. Raymond Hache actually made this initially. He made it as a capstone project for OSU because he was going to school there at the time. And it's really good. I've made some changes to it, hence my name's on there as well, but he did make the majority of it. Give him full credit here. He did most of it. But kind of like Roy, there was always some things that were not quite right. So over the years, it's been changed slightly, but it's not a lot. There are plenty of years worth of them on there. And I recommend you go watch like last year and the year before, because I explain it different every year. And sometimes I give other hints that I don't even realize. So just go watch it. Okay. AES, Advanced Encryption Standard, based on the Richendale Cipher. PIP standard in 2001. It says a system break in DES in 1 second, which we know doesn't happen, would take 149 trillion years to break AES. So it's a little bit better encryption than DES. Okay. Very good performance of both hardware and software. Works on a wide variety of computing environments. Variable block lengths, variable key lengths, variable number of cycles as well. Remember, that was an issue with DES. I mean, it was hard-coded cycles, hard-coded length, hard-coded key, hard-coded everything. Simplicity, low memory requirements, and the sound design. Okay, works good for pretty much any type of transmission with greater than 1 gigabit per second required for hardware. Yeah, hardware requires that. So. All right. Details. It says most ciphers use a Feistel structure, which means some of the bits in the intermediate states are simply transposed, named after the German physicist Horst Feistel. He uses 3 distinct invertible uniform transformation layers, and we're going to walk through all these. Okay, we're going to walk through byte sub, shift rows, mixed column, and add round key. You're going to be fine in all of them, but mixed column. That's the only one that's a little confusing. This is probably the most technical out of all of them. You really need to walk through the demo one first. Okay. Resistance to all known attacks, says speed, code compactness. It's just really good. Okay. And really no issues with it at this point. Okay. You've seen this before. Look familiar? Using the same exact one you did before. So if we took the word dog, we would go, 4 and 4. Then we would go 6, F. So coming down from the top. And O, I'm sorry, 6. What am I looking for? O. Oh, where is O? Oh, down there at the bottom. 6F. My hand was in front of it. I'm like, where'd it go? 6F and then 67 for G. So far, so good. Everybody should do this part. It's really the same thing you did in DES. Okay. Now, Cipher Key. Most of the time I provide this to you. I'm pretty sure in all the ones you're doing, I'm providing this to you. Okay. That's just the key to use. We use this to create our round key. Okay. Now, here's how we create the round key. We take the 82, the last column, the 8A2261BE, and we rotate it down. Why is this not doing animation? Oh, there it goes. Okay. So the 8A, basically what's happening is shifting it. Y'all see that? So the 8A goes to the bottom, everything else gets shifted 1 up. Okay. Then you take that, run it through the S box. So there's 22. We get 93. That goes over there. Then we get 61. We get EF. Then we get BE. I know why this PowerPoint took them a while. Then we take 8A and the 7E. All right, so now we just, the 37 is the first column. Let me go back to show you again. Now I gotta, okay, see the 37? So what we did is we took the last column, shifted it, ran it through the S box. Then we take those results and use them with the 37. Okay, the first column. All right, so all this again. So we take that 37, the column that starts with 37, and take the right column, the last column that we shifted and ran through the S box, and we XOR them together. And then we XOR that result with the archon value, which happens to be 01000. Okay? So far, so good? Let me show you how this works. So we take 37, convert it to binary, 93, convert to binary, then we XOR it. XOR is one or the other, but not both. So 0 and 1 becomes 1. 0 and 0 become 0. 1 and 0 become 1. 1 and 1 become 0. One or the other, but not both. Okay? And 0 becomes 0. So it has to be one or the other. Any other thing, it's a 0. So one or the other is a 1, everything else is a 0. See that? Then we got to XOR that with 0, 1. Okay? And we end up with that right there. Okay? Then we take that, which happens to be a 5, that goes way up there in the top. Then you take 89, XOR with EF, and we get 66. Oh, I don't have animation for that one. Then 3F with AE. We don't have to do anything with the third column because those are all zeros. Okay? And so on and so forth. We get 91 and then 12. So far, so good? So the 37 was the first column of our cipher key. The 93 column there, that was the right-hand column, shifted, ran through the S box. Then we XOR them together. Okay. Then we take that we just made, there's our original. Okay. So remember, we just made that A5 one. So now you bring down the second column, XOR it with that one. Watch where that one goes. And that becomes a third, and the other one goes back up to the second. So this one becomes the third. We take the fourth one down, XOR those together. That one goes up there, that one goes up there, and that one becomes the fourth. A little bit trickier than you've done in other ones. Okay? So far, so good? You're going to have to watch these slides. You're going to have to, or else you're going to get lost. Okay? That is our round key. Okay? Then we take our state and our cipher key and make a new state, and those are XORed as well. So 85 XOR with 37 gives us a B2. 1D XOR with 89 gives us 94, and so on and so forth. You just go straight through everything. Okay, on this one? Now, let me show you something here. I'm going to bring a handy dandy calculator here. I'm going to bring up programmer mode and put it right down here. So if I did 85, wait a minute, we're on hex, aren't we? We're on hex. There we go. Let's clear this thing out. Where's this clear button?
See above the 9. Above 9.
Oh, there it is. Okay. So now we're on hex. So we're going to do 85 XOR 37. We got B2. See that? So I'm going to do the right-hand one. So 45 XOR 8A. And if this works correctly, we should get CF. Get CF. Okay? This works most of the time. And you'll learn where it won't work here in a minute. Okay?
You could probably do each row, like a whole row at a time.
But you needed the individual values.
Yeah, I think if you put like 8516 D055 and then
let's try it.
With the second,
8516 XOR 37 4A.
4A. B25C, yeah.
Okay. As long as you have zeros in front, if there's okay, these are
as long as you put zeros.
Yeah, as long as there's 06, you put a 0 in front of it. So, all right. Okay. Now, subbytes. You're going to take the B2, run it through there, and get that. So B2, run through this table, gets you 37. Yeah, we're not going to walk through that one, but it is.
It's a big table.
Just a big table. Okay, now shift rows. First column, we don't shift at all. I do ask you for specific steps. Okay, then we bring that one over, then we shift it by 1. Come on. There it goes. 1. So it rotates that way. Then this one's going to shift by 2, so we're going to end up with 3F at the beginning. Then this one we're going to shift by 3, so we're going to end up with 6C at the beginning. Okay. Now the fun part, mixed columns. And let me pause this for just a second. Okay, we're going to walk through mixed columns here. When you use mixed columns, I gave you this worksheet right here. This will help you figure out which way they go. So just like I'm showing you on the slides in the back there, you see like that first column, 37 is actually an A, 4A is an E, 5D is an I, so on and so forth. And see these numbers here, the 2, 3s, 1, 1, those are right in here. Well, when you do this, we're going to walk through this real quick, then we're going to get back to this document again. And we want this one. Okay, here's how mixed column works. You take the leftmost column, multiply it times the top row, and then the leftmost column times the second row, then the leftmost column times the third row, and the leftmost column times the fourth row. That gives you 4 values. Okay? What that gives you is, okay, we're going to show you, we're going to do the math here in a minute. Then we do the second column times the top row, second column times the second row, second column times third row, second column times the fourth row, and so on and so forth. Okay? I'm going to show you how to do the math. Then you take the last column and times each of these. Now, since we got that one up there still, so if you notice, so the A1, so A times 1, XOR B times 2. Let me make this bigger in case some of you can't see it. Get rid of this thing. So A times 1, XORed with B times 2, XORed with C times 3, XORed with D times 4. All of that math gives you AA. Okay, see that? Then the second one, A times 5, XORed with B times 6, XORed with C times 7, XORed with D times 8. All of that gives you BB. So see how this works? I gave you this worksheet here because it's confusing without it. And you will not have to do this step on the test. But you have to do on the homework. And there's how you get each one. You did it in math, probably trig or something.
I think it was pre-calc.
Might have been pre-calc. I can't remember which one it's in. But. Okay.
Never properly learned how to do it.
So you see how to do this. Now we're going to see the math. So the first, we have 37, okay? What we need to do is convert 37 into an algebraic formula. So we need to multiply times 2, 3, 1. So let's do 37 first. So we got to do 37 times 2 because that was that middle chart. It was 37 times 2. Then 49 times 3, 3F times 1, 6C times 1. Okay? So far, so good? Now we're going to see how the math works. So here's 37. We convert 37 to binary. That's a 3 and that's a 7. Then we convert a 2 to binary. That's a 0, that's a 2. Then we put those numbers up. You need to know this top thing right here. Okay, since it's not on the test, you can write this down. I don't care. So 37, the way this works is we got x to the 7th all the way through 1. So 37 is 0x to the 7th, 0x to the 6th, 1x to the 5th, 1x to the 4th, 0x to the 3rds, 1x squared, 1x, and 1, 1. See how that works? So you see how we ended up with x to the 5th, x to the 4th, x squared, x, and 1? It's literally, if you draw that top thing out, you can literally put the binary underneath it. Okay, then we got to do the same thing with 2. So what's 2 going to be?
X.
Just x. Y'all see that? So 2, when we put those zeros up there, so if I was to put, we need 0, 0, 0, 0, 0, 0, 1, 0. Okay? Y'all see that? That's 2. Y'all agree with that? Mm-hmm. So it's literally just x. Okay. Now, back to algebra days. It's not hard. Now what we need to do is multiply them. So you take the 37, which is x to the 5th, x to the 4th, x squared, x and 1, times x. What that does is it increases this exponent by 1. So x to the 5th becomes x to the 6th. X to the 4th becomes x to the 5th. X squared becomes x to the 3rd. X becomes x squared, and 1 becomes x. Easy enough? That's how we multiply. Then you convert it back to binary and hex. So when you're converting that back, what we have here is we have no x to the 7th, but we have an x to the 6th, x to the 5th, we have an x to the 3rd, okay, and an x. So we do 0 there, 0 there, and when you divide it in half, that will give you a 6e. Okay? It's not hard. It's just a bunch of steps. Okay? And I wrote a Python program that does all this so far, but the next part is where I stopped and never finished it. Now, let's try something else while we're still on the same page. So let's take 37. We're going to go to hex. 37 times 2. 6e. See that? Makes your life much easier, doesn't it? But it won't work every time. And you'll see.
Python to do binary multiplication like that?
Sure. No problem.
So I can figure out.
Yeah, you can do it. All right. So y'all see how I just did that with the calculator? But it won't work every time. I'll show you where it won't work. Okay. So that's how we got the first value, the 6e. Actually, remember, that is just the 37 times 2. Then you got to do the same. Click back in here. Do the same thing for the 49 times 3. 49 times 3. Get that. So when you multiply that out, so remember, it's now since we have to take 6, or x to the 6th, x to the 3rd, and 1 times x plus 1. So we have to, so x to the 6th becomes x to the 7th, x to the 3rd becomes x to the 4th, and 1 times 1 is, 1 times x is x. Okay? So we just did the x. We just did this part right here. So then now we also have to add again x to the 6th, because x to the 6th times 1 is x to the 6th. So we have to add again x to the 6th, x to the 3rd, and x to the 1st. Okay. Then we can put them all back in order and get that. And we end up with 1, 1, 0, 1, 1, 0, 1, 1. Because you convert it back to binary and it ends up being dB. Okay? With me? Hopefully somebody is paying or catching a little bit of this. So you really need to walk through the sample I'm going to show you in a minute, because that has all of them in there. Then 3f times 1. Obviously, any number times 1 is what? Itself. So 3f times 1 is 3F. So there's no sense in doing that one. Okay? Which I did it anyway, but you're not. And 6C times 1. Then you take those values. Remember, all those times those gives you that first column. Oh, there we go. 6E, XOR DB, XOR 3F, XOR 6E, XOR E6 gives us all those. So, yeah, that was the answer to it. So, takes a long time to do it. But if you look at that PDF I gave you, it tells you exactly how to get each block. Okay? Took forever to make this darn PDF. See, Raymond didn't do that part. Okay. Now there are some problems. There's something called a Gloyus field. This is the part where I didn't finish my program. The Gloyus field is needed sometimes. Okay? Let me show you when. So say we got E7 times 3. So E7 converted to binary is this right here. Okay? And that becomes x to the 7th, x to the 6th, x to the 5th, so on and so forth. And 3 becomes this, which is x and 1. So when we multiply this number times this, what do we end up with? Get an x to the 8th, don't we? But let me go back a couple slides. I need to bring that over. Almost there. What's the highest number we can handle? 7. We can only handle x to the 7th, so we got to do something to fix that. All right, so that's where the Gloyus field comes in. Because if we take this number here times x to the 1, we're going to end up with x to the 8th, x to the 7th, 6, so on and so forth. Then we multiply times 1, and we get the same number again. Now, I don't know the name for this next step, but whenever you do this, you cross off duplicate values. So in other words, you got 2x to the 7th, get rid of both of them. You got 2x to the 6th, get rid of both of them. There's a name for it in math. I don't remember the name. Okay? So you cross off all the duplicates, and we end up with x to the 8th plus x to the 5th plus x to the 3rd plus 1. Since that number's too big, remember we can't handle anything over x to the 7th, you have to XOR it with the Gloyus field that never changes. And what that does, now we have 2x to the 8th, so they cancel each other out basically. And we end up with that number there, which in this case is 32. So let's try calculator again. So if we did hexadecimal E7 times 3, 2b5. It's too big. Has to be 2 digits.
Yes, and then you can XOR with the.
Yes, you can. You can XOR with the Gloyus field. But you'd have to convert the Gloyus field to hex first.
Yeah.
Actually, I guess we could convert that to binary.
Yeah. Just
Convert it to binary. Then XOR it with 0, 0, 1, 1, 0, 0, 1, 0. Comes up to that. No, still too big.
I think you're supposed to put a 1 at the beginning.
Yeah, maybe.
For that state.
Oh, yep, I did the wrong one. Darn it. Okay, let's do it again. Yeah, I did the wrong one. So E7 times 3 give us this.
Binary.
Have to convert to binary. Then XOR it with this number. I did the wrong one. 1, 0, 0, 0, 1, 1, 0, 1, 1. Gives us that. Convert it back to hex. There's a way to make it work. I just can't remember exactly what it is. There is a way to make it work. It's just not. I can't think of what it is at the moment. It is on one of the recordings. I just don't remember which one. Okay. So when you have a number that's too big, in other words, it's any of the 3s and some of the 2s will cause it. So if you're doing the calculator and it's more than 2 digits, you got a number that's too big. Okay? That way you can check it. All right, and then the last step, this XOR that gives you that. That's it, you're done. That's state after mixed columns. There's your round key, and it gives you your ciphertext. All right, we're not, stay right there a minute. I'll show you one more thing. Okay, this is up there as well. This is a practice worksheet. It's exactly like what the homework uses, but you're using this word here, using computerized 1357. Okay, this is done for you. So that word ran through this, gives you this state. There's a cipher key, there's the S boxes, and you can walk through each one. Now, when you see something like this, what they're saying is that's the same one from above, right? It's this one. There's the state. So that's state from above, then you get state 1, then this is state 1 from up here, same from above. See, in the past, years ago, I would literally just grade the last one, right here. But guess what happens if you screw up something in the middle?
0%.
It's all wrong. Exactly. So then I literally went through grading every single block. And that sucked terribly. Because, I mean, because imagine this. If you mess up something right here, it's going to screw up everything after that point, isn't it?
Yep.
So then you're kind of screwed. It's like, so I would literally have to sit there and try to figure out what you did. So now when you're doing it, I give you state and the cipher key, and you got to give me state 1, for instance. Okay? So none of your homework questions build upon each other. I give you the state and the cipher key, and you got to come up with state 1, or whatever. You know, I give you state 1, and you need to come up with state 2, so on and so forth. Okay? Like I'll give you state 3, and you have to come up with state 4 using the matrix. Okay? Then I'll give you state 4, and you come up with the ciphertext, and I also give you the round key as well. So I give you these 2. That way, if you screwed up state 4, you don't have to worry about it, because the next question, I'm giving you a different state 4 and the round key, and it comes up with ciphertext. Please walk through this just so you know how it does. And I think the practice is only 1 step. I remember right. I don't remember. So please walk through this practice sheet and make sure you use this matrix on how to do the matrix. Okay? Is anyone totally lost?
Yes. I just gotta rewatch it.
Yeah, you just need to watch it and walk through the matrix, at least a part of it. Walk through the work, at least so you can get like 1 block in each or something, so you know the steps. It's not hard, it's just a bunch of little steps. Write them all out, because if you have problems, I need to be able to see your math. Sometimes I can't get that, how do you get a C5 or whatever? Well, what did you do? So try to, you know, write it out, like get a notebook and write it all out or something. That way we can, you know, at least follow it. Okay? All right, so that is the end of this lecture.